Mr. Owl says hello. He's from Russia. Say hello, Mr. Russian Owl. Today we're going to talk about the 4 different kinds of chemical reactions that you need to be able to identify. The first one, okay, so types of chemical reactions. Okay, RXN stands for reaction. And the first type of chemical reaction is called a synthesis reaction. Some books call it a combination reaction. So if you happen upon this looking at another book or on a website, synthesis or combination. Combination is exactly what it says it is. You have 2 reactants form a single product. Okay, so 2 reactants form a single product. Your book has a generic form for this equation. I think they use X. I'm going to be using A. So it's reactant A plus reactant B goes to product AB. So A is separate, B is separate. They come together in the right orientation and they make a product AB. A and B can be molecules or they can be elements. We're going to stick with elements right now. So suppose I have magnesium and it reacts with oxygen. It would form MgO. Now the charges are right there. Magnesium is always +2. Oxygen is generally -2. They're going to combine in a 1-to-1 ratio. So this looks very much like A, B, and AB, except there's one little problem with that. That's not how we represent oxygen. When you start representing the elements the way they're supposed to be represented, this may not look quite so similar. So if we write magnesium plus O2, which is how we write magnesium oxide, or oxygen, you'd still get MgO, but that equation's not balanced. So to balance it, I need 2 oxygens on this side. I'm going to put a coefficient of 2 in front of the magnesium. Now my oxygens are balanced, but my magnesium is not. So I have to add a coefficient of 2 in front of the magnesium. It's still a combination reaction. You have 2 elements coming together to form a single product, but it looks a lot more complicated than it did in this form. So that's kind of the tricky part. The next one is the opposite of a synthesis reaction. It's called a decomposition. A decomposition reaction is 1 reactant forms 2 or more products. So 1 reactant forms 2 or more products. Generally, you can only have 2 reactants going together because they have to be oriented properly in order to form that product. With a decomposition, it can break apart into many more pieces. The generic form for a decomposition is compound AB gives you A plus B. If we did the magnesium oxide, it would be exactly the opposite. 2MgO goes to 2Mg plus O2. That's balanced. It's 1 reactant forming 2 different products in terms of their identity. It doesn't matter that there are 3 atoms, just that there are 2 different products. The next reaction is called a single replacement reaction. A single replacement reaction basically is like replacing like. What this means is metals will replace metals and nonmetals will replace nonmetals. So one metal replaces another, or a nonmetal will replace a nonmetal. Okay, the form for this is A plus BC goes to AC plus B. Now, if this seems kind of weird, think of A and B as being potential cations. Cations always get written first. So the metal, which wants to be a cation, goes in and replaces the other metal. Or another way to think of it is those old movies with like Fred Astaire and Cary Grant, and everybody's dressed up and they're out at a nightclub, and somebody goes up, say Cary Grant, touches some other actor on the shoulder and says, "May I cut in?" And the actress, be that whoever it is, say Lauren Bacall, going way back in time, says, "Oh my." And so this actor goes away off to the bar to have a cigarette and a drink, and Cary Grant dances off with Lauren Bacall. See Cary Grant, Lauren Bacall, and then the guy who got cut in on, who's off smoking a cigarette in the bar being sad. So it's similar to cutting in at a dance. So let's take a look at magnesium plus, let's not do that. Why not? Magnesium plus zinc chloride, ZnCl2. Magnesium and zinc are both metals. Chlorine is a nonmetal. Magnesium will replace zinc. Now, magnesium is going to be a plus 2 cation. Zinc is already a plus 2 cation, and each chloride ion is minus 1. Minus 1, minus 1. So what will happen is magnesium will take zinc's place. You get MgCl2 plus zinc. Zinc is the poor guy off in the bar smoking a cigarette. Okay, now, last one is what is known as a double replacement reaction. In a double replacement reaction, you have two metals trading places with each other. Crazy as that sounds. So we have, for the most part, metals trading places. This will take the form AB plus CD goes to, okay, cation, cation. So A is going to trade places with C, and you get AD, cation, plus C will end up with B, CB. So we have the cation. Why don't we make those look like cations by putting a plus sign under them? The cations have just switched partners. An analogy for this is you have gone to winter formal with your best friend forever who doesn't have a date, but you guys have decided to go together. So he gets dressed up, you get dressed up, and you happen to see the guy that you really want to go with, and he's with his best friend forever because neither of them had a date, and the four of you end up talking, and before you know it, you are suddenly dancing with the guy you were crushing on, and your good friend from like kindergarten is dancing with the girl he was crushing on. So there's your best friend, there's the girl he was crushing. Wait. Let's do this again. There's your best friend, there's the girl he was crushing on. There you are, there's the guy you were crushing on, everybody's happy. Okay, an example of this. HCl plus NaOH. HCl is plus 1, chlorine is minus 1, Na is plus 1, the hydroxide ion is minus 1. So the H is going to replace the Na. So we have HOH plus 1, minus 1, otherwise written as water, plus Na plus 1, Cl minus 1. Okay, so what you need to be able to do with all of these is to identify them. If I give you a reaction like this, you need to be able to say it's a double replacement reaction. That's it.